Okay. I'm now recording and we are in 2.6. And for those of you who are just joining the recording, all I did was talk about the parent function to begin with. So you can pause and look at that before you join us if you need to. Okay, everybody else. So we got to talk about the parent. We know what it looks like. Now I'm going to tell you how we find our asymptotes and intercepts. So I'm going to make like a little key down here at the bottom. So down here, I'm going to draw a little key. We're going to talk about vertical asymptotes. We're going to talk about horizontal asymptotes. We're going to talk about x-intercepts, and we're going to talk about y-intercepts. So those are the 4 pieces of information that we need. So this is like a really important box that we're going to fill in. As I tell you what each one is, we're going to use example A as our like walking through to solve it. So the first thing we're doing is vertical asymptote. To do my vertical asymptote, we have to set my denominator equal to 0. We have to set my denominator to 0, and that tells me my vertical asymptote. Once we sketch, we'll talk more about what asymptotes look like. So what I'm going to do is I'm going to go up to the top now and set my denominator equal to 0 to find my vertical asymptote. I do like to label everything on my picture or on my work. So I'm going to write VA, and then I'm going to set the denominator, which is the bottom, x minus 3 equal to 0. Add 3 to both sides, x equals 3. Okay, cool. That's going to be my vertical asymptote. And we did this, I think, at one point, so this should be a little bit of a review. The next thing is the horizontal asymptote, and this is the hardest one because there's multiple like steps to know. So horizontal asymptote depends on your exponents. So you could have the exponents be the same. If my exponents are the same, then we look at the coefficients and make a fraction. Look at coefficients. Let's just use like A and B as like numbers. So it could be 1 and 1, it could be 2 and 3, it could be -5 and 10. I don't know what it is, but if I have my exponents are the same, 2 and 2, then I look at my coefficients and my horizontal asymptote would be y equals A over B. That's the most common one, so that's why I did that one first. And we've done that before. There's 2 more though. If my exponent on top is smaller than the one on bottom, so I have 1 over, like an exponent of 1 over an exponent of 2, then that's just y equals 0 every time. And then the last option is if the exponent on top is bigger than the one on bottom, that's when we need to divide. You can either do long or synthetic division, it doesn't matter. And you're going to get an equation of like a line or a parabola maybe, I don't know. A lot of times we get lines and it's a slant asymptote. So instead of just being like a horizontal line, it's slanted, it looks more like this. And we will not get to those today, but we will get to those tomorrow. Any questions on the horizontal asymptotes? Okay, I'm gonna jump over and do the horizontal asymptote on letter A. So I'm gonna jump back up and do my horizontal asymptote here. Unless it's a dividing one, there's really no work. All I have to do is I look at my equation, I have x and over x. Well, they both have the same exponent, which is just 1. So I look to their coefficients. If there's nothing written there, it's 1 and 1. So my horizontal asymptote is just y equals 1. One and 1, and I just use those. Questions so far? Okay. Next are x and y intercepts. To do my x-intercept, we want the numerator to be equal to 0. So to find your x-intercept, set numerator equal to 0. The reason why that works is because if my numerator is equal to 0, then that whole equation is 0. So if I have 0 over literally anything, so I'm going to put like a little box that can be anything, then that answer is always 0. So that's why I only want to focus on the numerator. So to find my x-intercept, I'm going to set my numerator, which is x plus 1, equal to 0. Minus 1 from both sides, I get x equals -1. Questions so far? Okay, and then the last one is my y-intercept. If I have a y-intercept, that means my x's value is 0. So to find your x-intercept, we're going to plug 0 in for all of my x's. So I'm just using my original equation and having 0 be plugged in for all of my x's. So that would look like if this is my normal function up here, to find my y-intercept, I would do 0 plus 1 over 0 minus 3. And I usually set that equal to y just so I know later it's a y-intercept. The zeros go away, so I'm left with y equals 1 over -3, which is -1/3. Ooh, that was way bigger than I wanted it to be. All right, questions on how I got any of these values yet? No? Okay, we're all hanging in there? Okay, let's sketch it now. When I say sketch, it does not mean be perfect, but I do need to see all of these 4 pieces of information that I have. You can graph either your intercepts or your asymptotes first, whatever makes you happy, but we're gonna graph them all together on the same picture. So I'm gonna draw my graph down here. I'm gonna draw it off the line so we can see what's going on. Let me put some tack marks. And I'm gonna graph my asymptotes first. So my vertical asymptote is the one that goes up and down at x equals 3. My horizontal asymptote is at 1. Now I'm gonna do my intercept. So my x-intercept is at -1. So I'm gonna go put a point at x equals -1. And then y is at -1/3. This is just a sketch. I'm not gonna be like, oh, you put your point at -3/4, not -1/3, so you get points off. Just put it somewhere between 0 and -1 and it'll be okay. So that's fine. Nothing too crazy. All right, if you look back at the parent graph, do you see how I have one of my C's like in the bottom left quadrant and then the other one's in the top right? They're just always gonna go catty corner of each other, and my intercepts help me know like which quadrant I kind of start in. So this one I'm starting in that bottom left, just like my parent graph. I'm gonna go close to my asymptotes but never cross. I'm gonna go through my intercepts. Remember that the property of an asymptote is that we like approach it, but we never cross it. So we get really, really close to it, but we never cross it. All right, and then since it's in the bottom left, I'm gonna go in the opposite quadrant. So I'm gonna go over here and do a little curly Q over here. So get close to my asymptotes, get close to the asymptotes. There are no points I need in that top quadrant because there's no intercepts, there's no reason to find anything. We're just drawing a little C over there. Okay, any questions? Everyone doing okay? All right, I want us to do the next one. So we're gonna do vertical asymptote, horizontal asymptote, x-intercept, and y-intercept. If you're feeling crazy, you can go ahead and get started, then check back in with me, but I'm gonna get started in 1 second, okay? I'm just fixing my graph. So on all of these, when it says sketch, you have to find those 4 pieces of information before you do anything else. For anybody who still needs a little bit of hand holding, here I am. Vertical asymptote is the denominator. So I do x equals, nope, I do my denominator 2x squared minus 8 equals 0. Set it equal to 0. Add 8 to both sides, 2x squared equals 8. Divide by 2, x squared equals 4. Square root, x equals plus or minus 2. Ooh, we have two vertical asymptotes here. That's going to be interesting in a second. Can't wait to see what's going to happen. All right, HA is just my exponent, so I need to see if they're the same, if one's smaller or if one is bigger. It looks like they're both x squared, so it looks like they're both the same. So I'm going to say my HA is my fraction of my coefficients. So there's no number in front of x squared, so it's just 1. So it's going to be 1/2. Okay, kind of small, but that's whatever. It's okay to be that small. Now I'm ready for my x and my y intercepts. My x-intercept, let me go down, it says set my numerator equal to 0. Okay, set my numerator equal to 0. So x squared minus 1 equals 0. Everyone hanging in there? Don't be afraid to stop me if I'm moving too fast. Add 1 to both sides, I get x squared equals 1. Square root, x equals plus or minus 1. Ooh, now I've got two x-intercepts. The plot thickens, it gets interesting. All right, and then the last, like mathematically last algebraic thing we need to find is my y-intercept, which means I plug 0 in for my x's, okay. So my y-intercept is y equals 0 squared minus 1 over 2 times 0 squared minus 8. Yep, I copied that right, okay. 0 squared goes away, 0 squared goes away, 2 times 0 is 0, so I get y equals -1 over -8, which is just +1 over 8. Hint, you often get a lot of fractions in this kind of thing, especially with the y-intercepts and the HA. Fractions are common, so don't let that freak you out or think that you're doing something wrong. Any questions on what I found so far? All right, let's graph. Make it a little bit longer. So I can do 1, 2, 3, 1, 2, 3, 1, 2, 3. 1. Tried to make my scale just a little bit bigger this time. Again, it does not matter if you graph your asymptotes or your intercepts first. They don't, they're not dependent on each other. They just are their own thing. So don't forget we have two vertical asymptotes. So I'm going to have two lines that go up and down, and it's through plus and -2. So I'm going to go 1 on +2, and I'm going to do 1 through -2. My y-intercept was at x equals, or y equals 1/2. I said all of that wrong. My horizontal asymptote is at y equals 1/2. So I'm going to go graph this through 1/2. So my asymptotes are all up. Now I got to do my intercepts. So I'm at plus or minus 1 for my x. So I'm going to +1 and -1 on my x-axis. And then I'm going to 1/8 on my y-axis. Questions so far? So the one thing that we know we can do is we're going to connect the dots that we have. This actually gives us like an upside down looking parabola in this quadrant of the graph. When this happens, I'm going to go zoom out so you can also see my parent function again. I made a point to say we're in the bottom left and then we're in the top right, so we kind of went catty corner of each other. When you have like 3 columns like we have now, I have 1 column, I have a 2nd column, and I have a 3rd column. We're still going to go kind of catty corner of each other. So since I'm in the bottom one for the 2nd like column, I guess, the two on the outside, we're gonna be on the top. So again, since we were in the bottom down here, we're gonna have graphs in the top parts over here. They're gonna be just little c's like the parent function. The only reason I know this is because I know what the graph should look like. And now that we're talking about it, that's how you're going to know what it is. And we'll just keep doing more practice. So you're gonna see that this is like a trend that keeps happening. But I like to remember in my head that like they go opposite each other. So if I'm in the bottom in the middle, then I have to go up on the right side and on the left side. Okay, any questions? Okay, we've officially finished the first packet. So we just have like this little bit on here and the rest we had already finished and taken our test over. So we're gonna put that aside. And if you're on paper, we're moving to the next one. I actually put all my notability in one file. So I'm just moving right on down to the next part in here. We're gonna do, I wanna do these two problems and they require us to sketch. And then they've got this funny notation off to the left side. We're gonna deal with that funny notation in a second, but I want you to first solve these out. 20 years later, I've erased everything. Everybody know where we're at now. We're on the new note sheet. If you need to go back to Schoology and get it, great. If you have it on paper, also awesome. We have to sketch this first and we're gonna ignore this first. So don't like cross it out, but we're just ignoring that for a second. So I'm probably gonna go down here and put my work for this down here. I'm gonna do my vertical asymptote, my horizontal asymptote, my x-intercept, my y-intercept. Some of you might be working ahead. Some of you might be like, Miss White, where are you? Here I am. I'm with you. Let's do it. All right, vertical asymptote. We just made our notes on the other side, so you can remember, go back and look to see what vertical asymptote is. Set our denominator equal to 0. X minus 2 equals 0. Add 2 to both sides. X equals 2. Perfect. Now horizontal asymptote. It looks like my exponents are the same. They're both 1. My coefficient in front of both of them is 1, so my horizontal asymptote is y equals 1. Next, I have to do my x-intercept, which is set the numerator equal to 0. X plus 3 equals 0. That should be pretty easy. So x equals -3 is my x-intercept. And then last is my y-intercept, which is where we plug 0 in for all of the x's. So y-intercept is y equals 0 plus 3 over 0 minus 2. All right, the zeros go away and I'm just left with -3 over 2. We doing okay with this? Can I get some thumbs up? You can give me the emoji or give me your real thumb up if we're doing okay. I see 1 thumb, I see 2 thumbs. 3, 4, 5, 6, awesome. Everyone know where to find your little thumbs up? It's like, actually, I don't know if I can do it. I think there's like a little button next to you that you can press it. Okay, if you don't know, maybe ask a friend. I don't know how to do it off mine. Okay, awesome. Everyone's with me. At least most of you are. Let's graph these. So I'm gonna go graph my asymptotes, graph my intercepts. I've got +2 as my vertical asymptote. Whoa, that is not a line. It's only marginally better. Y-intercept is at 1. My intercepts are at -3 and -3 over 2. -3 on the x-axis is easy to find. Remember, -3/2 is between -1 and 2. So again, just somewhere between -1 and 2 is fine with me. Now we're going to draw our little C in that bottom left because I know that's where my intercepts are. So something like that. It's a little flat, but it's fine. Same idea for the one up top, just we've got a C in there approaching my asymptotes. That's kind of all we can work with. All right, so half the battle was just sketching it, and we need the sketch in order to do what we're about to look at on the left-hand side. Any questions on what we've done so far? Okay, now we're going to move into this new notation, and I don't know if I've talked to you guys about this or not. I'm gonna act like we've never seen this, okay? This is what we call limit notation, and this is what you'll see in calculus. So anyone who takes calculus, you'll do a lot of limit notation stuff or any higher level math. It's been a minute since I've taken those college classes, but there's a lot of this limit notation. You don't have to have an extensive knowledge of it, but we need to have a little basic understanding. So what this is it's asking us for like the limit of my function as x does something. So we're always going to be looking at y. Remember, f of x is your y. So we care about what is y doing. This down here tells me what x is doing. So like in my head, I'm kind of thinking, okay, what does y do? And you don't have to write down my like verbiage, but this is what I physically think in my head. I'm like, what does y do when x, and this arrow means approaches or gets closer and closer to? What does y do when x approaches whatever this number is? So in our case, it's infinity. I'm thinking in my head, what is y doing when x gets closer and closer to infinity? Or as x gets bigger and bigger, as x approaches infinity. So that means when we're looking at our picture, we're looking at x getting bigger and bigger, and we're asking ourselves, what does y do? So I'm going kind of left and right on my picture to either get bigger and bigger or smaller and smaller or close to a certain number. And then we want to see what the function is doing and where my y value is. So let's look over here. So we're looking at as x approaches infinity. Well, x is my axis down here. This is 0, and this is 1, 2, 3, 4, etc. If I'm looking at x getting bigger and bigger or going to infinity, I'm going this way. So I'm essentially following my like pink curve and saying, okay, what is my function doing? What is my y doing as my x gets bigger and bigger? So as my x gets bigger and bigger, I'm going this way. My y value is getting closer and closer to that asymptote. It's never going to cross it, but it's going to get closer and closer to 1. And so my answer is just 1. If it's not a sun light bulb for you, which most of it won't be, just like let it sit for a second. Let's talk through a couple, and then maybe you'll start understanding it. So my limit as x approaches infinity is 1. Now we're asking ourselves, okay, what does y do when x approaches negative infinity? So now we're going to where x is getting much smaller, smaller and smaller. So I'm going the other way on my x-axis. I'm going this way. As x gets smaller and smaller, my function is getting closer and closer. It's also approaching the asymptote just from the other side. It's also getting closer and closer to 1. Getting closer and closer to my asymptote. Okay, we often check what we're doing at the ends, at the infinities, but then we also sometimes check this important point in the middle, which is where my vertical asymptote is. So where x is 2, there's a change. We see that there's something going on with my graph. When it says 2 with a little plus sign behind it, it means that we're coming from the right-hand side. So we're coming from the right and looking at it that way. I don't know why this has a little 1 behind it. Cross off the 1, it should just be a negative. If the 2 has like a little negative superscript behind it, it means that we're coming from the left. So I'm coming from this way and I'm looking at what I'm doing at 2. This is not like a pre-cal thing, but like if you go farther in math, what this is saying at the calculus level is like if the limit at these two is not the same, then it's not a continuous graph. We know this is not continuous because our definition of continuous is like, did I pick up my pencil? The definition at calculus is if the limit from the left and the right is not the same, then it's not continuous. And we're going to see what it is in a second. So now we're going towards 2 from the right. So that means I'm coming at it from this side over here. I'm starting over here and I'm going to work my way up the graph. As I'm getting closer and closer to 2, which is that highlighted axis, my graph goes higher and higher forever. It's approaching positive infinity. My y, as I get closer and closer to 2, goes up, 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 up. It goes towards positive infinity. Okay, now we're going from the left-hand side. So I'm going from the other way. I'm coming from over here, and I'm going to move my way down the graph. As I'm getting closer and closer to 2, it looks like my function is going down forever. So that means it's approaching negative infinity. All of your answers for these limits will either be a number, one of the infinities, or does not exist. And we'll worry about that when that happens. I don't know if we're doing does not exist at pre-cal, but that is an option. So usually your answer is just a number or infinity. Anybody have any questions on those? Anything you want me to talk about further? Okay, I know it can be confusing, so don't be afraid to ask.
Why is numbers or letter C infinity? Can you explain that again?
Yeah, so why is letter C infinity? So we're getting closer to x is 2. So we're going towards this line right here, and we're looking at what my function is doing. We're coming at it from the right side, so I'm coming at it from over here, and I'm just following my line and seeing where my line goes. As I follow my line, I'm getting closer and closer to 2, and my graph goes up. So it's going to keep going up forever and forever. It's going to get close to 2, but it's never going to cross over 2. So it's going to go up towards positive infinity. Does that help a little bit?
Yeah, I was looking at the bottom line instead of the top one.
Okay, very good. So that's why the little plus and the minus help us. Very, very good point, Jared. Okay, any other points? Any other questions? All right, let's do another one and see if we can do this again. So this one starts with sketching. So I'm gonna be quiet for a second, and I want you to find vertical asymptote, horizontal asymptote, x-intercept, y-intercept of this new graph. And again, I'll probably do my work down here. I'm gonna take attendance really quick though. All right, so I'm doing my work off to the side. Check in if you want to check yours. All right, check your vertical asymptote, check your horizontal asymptote, check your intercepts. Any questions on those? Okay, let's graph them. -2 and +2, okay. And then -1/2 and +1/2. Once you graph your points, let's connect the ones. It looks like now we're in the bottom right, and that's okay. That's just where our points happen to be. So I'm gonna have one of my C's down here in the bottom right, and then I'm gonna have another C up here in the top left, because again, they have to go kind of catty corner of each other across the way. Cool, any questions on your graphs? Everybody got them? All right, let's look at our limit notation. Now let's walk through it again slowly. Okay, the first one says the limit of f of x as x approaches infinity. So what is y doing as x gets bigger and bigger? So x is getting bigger and bigger and bigger. It looks like my function is getting closer and closer to my asymptote, which is at 2. Okay. Then
I thought it couldn't touch 2.
Okay, good question. It does not touch 2, but it gets closer and closer to 2. So you will never ever touch 2. So this is not saying what is f of x. It's saying what are we getting close to.
Okay.
Good question, Jared. Same idea on the other side. Now we're going to negative infinity. So we're going as far to the left as we can go. And it looks like my graph is also approaching the asymptote. Again, we'll never touch, but gets closer and closer to 2. We okay with that? Okay, now we're looking at -2, which is this asymptote right here. And we are looking at, the first one is -2 with the plus sign, which means -2 from the right. So we're coming from this direction to look at my -2. I'm over here. I'm going down, I'm going down, I'm going down. Whoops, sharp drop. As we get closer to 2, we are hitting this negative infinity. We'll never reach negative infinity, but that's the direction we're going towards. Again, we're looking at the y. So if I'm like at my y-axis, if I'm going down, I'm just getting lower and lower and lower. So that's how I know it's negative infinity. And now same idea, but now we're going from the left. And so I'm coming from all the way over here and I'm approaching my -2 approaching. It looks like I'm going up forever. So that is positive infinity. Hint, our asymptotes are super helpful here. So like when we are approaching positive and negative infinity, we're looking at our horizontal asymptote. when we're approaching the vertical asymptote, you're going to one of the far ends, either positive infinity or negative infinity. So that's kind of also a way to help you keep everything in check. Okay, any questions on this problem? Any questions at all? This is going to be our stopping point for today. So we're going to come back tomorrow and look at number 4. I have not assigned any homework yet. So again, this is a good day to get ahead on anything else that you're missing. I'll be available during Flex if any of you want to talk. And we still have 5 more minutes in class, so you're welcome to hang out with me or you're welcome to continue on with your day. Happy morning to you guys. I miss you. I hope that we're doing well, and make sure you get help if you need it, okay? Have a great day.
Thank you.
Thank you.